Okay. Okay. So last class we had discussed about the Kubernetes. What is Kubernetes and what is the usage of that? What is the benefit and importance of Kubernetes? Also, we had seen the other details, objects and all about the Kubernetes. So today we'll see more details about Kubernetes. What is the architecture and how the Kubernetes flow works and all. Okay. So just give me 1 second. I'll just share my screen and we'll discuss further. Okay. So if you can see my screen here, the Kubernetes architecture. Okay, so this is the simplest Kubernetes architecture, but it has a lot more to discuss, and the discuss into the end-to-end flow and all these things. We'll discuss how it works. Okay, so what is this architecture says? Like here, the APIs, the clients, right? Suppose if you want to launch an applications, or your team is wants to launch an applications, either you have to use a API, some sort of API to write a program, or API, or CLI, or GUI, like user interface you can use, or the command line interface, or the application interface you can use to launch your application. Then what will happen? The Kubernetes master will decide where it to be launched. Based on that, the nodes, the worker nodes, because the master will distribute the task or the request to the respective node based on the configurations. Okay, so we'll discuss further on these configurations, how these configurations work, and how we can create and set up our own configurations. Now, what happens here? Let me make the slide slow. Okay, so what it says, the container orchestration is all about managing the life cycle of containers. Okay, suppose you can see here in this diagram, we have three nodes. Okay, VM1, VM2, and VM3. We have three virtual machines, and we have currently two nodes. Our applications are there, and one node is in standby. Okay, suppose in case what will happen, these three nodes are there. In case something happen, one web server application got terminated, or something happened, it just killed out. Okay, and suppose due to some resources availability or something, that is stopped or terminated, what will happen? The Kubernetes itself will monitor all these things, and then automatically it will create the web server in available another available node, or the virtual machine. In this way it will manage the applications, and it will maintain the applications, make sure that there is no impact to our organization. Okay, so the next thing is, 1 second. So where does the Kubernetes live? Why does the Kubernetes live? So you'll see, like Kubernetes, the short form is K8s. K8s. So if you see here the Kubernetes, okay, K, and after that it will be in between K and S, there are 8 letters. Okay, 1 2 3 4 5 6 7 8. That's why they have given a name as K8s, Kubernetes. And it also, the pronunciation K8s also sounds as Kubernetes. Okay, now anywhere we need it to, like for education and training purposes, what kind of Kubernetes you are going to use, like the cluster, how you will create the cluster, what are the tools you are going to use for the Kubernetes. For evaluation and training purpose, like what we are doing, we have to like install the Minikube Kubernetes and work on that. For development purpose also, most of the companies or organization, they use Minikube and Dev Cluster. There is one called Dev Cluster Cloud, that is AWS or other cloud service providers. They provide a development environment where you can use the Kubernetes for development purposes. And the other one will be the deployment. Deployment is in the production. So productions will be using the kubeadm, COPS, cloud provider, or bare metal. There are many other service providers who provides the Kubernetes service also. for their they have their own application, their own service they're providing with the different names. Okay, and mostly we are going to if you are going to create a cluster or going to work on the Kubernetes, mostly we'll be working on this kubeadm and kops. Okay, just remember these terms. And so far we are going to work on Minikube. Okay, I'll show you how to install the Minikube. Also, I'll show you how to install the Kubernetes and the other tools in the production environment also. Okay, the production environment, high availability structure, how we can make it multiple master, multiple nodes, everything I'll show you. Okay, but for the time being, we'll just continue with Minikube until unless we are get good knowledge on Kubernetes to work on. Then we'll move into the production environment. Like we'll create a simulation, production like simulation, and then we'll work on that. Okay. The next is okay. Here, if you see this architecture diagram, okay, that architecture, whatever I was showing, it was just a demo small diagram. That is, if you correlate that one, we are going to see the more detailed about this architecture, how the Kubernetes flow works. Okay, you can see in this diagram we have two servers, like one is master and the other one is the node. Okay, the master, you'll be get question like what the master contains. Remember, the master contains these four components. These four components, one is the API server, the scheduler, the next one is the controller, and the other one is the etcd. Okay, we'll discuss more detailed about each component, and for now we'll see how the flow works. And you can see here there is one is kubectl or kube control. You can spell it either kubectl or kube control. This is the command line interface through which we can interact with the Kubernetes services. Okay, and here the node will actually host or deploy all the applications. Okay, your applications, your product, everything will be hosted in the node machine. Let's see how it works. If you see here, the kubectl sends the request to the API server. Then API server scans the etcd. Etcd is nothing but the etcd database. Okay, etcd etc. etcd database. It's a database which stores all the informations about the master, about the application, about the node, about the cluster. Everything will be stored under this etcd database. Okay, what happens once the kubectl, the client sends a request to the API server scans the etcd database, and then the information goes back to the API server. Then API server will send a request to the scheduler. The scheduler, what will do, it will just get the informations what needs to be done, then sends back to the API server. The API server then talk to the node using this kube-proxy. Okay, and then what happens, the kube-proxy will talk to this kubelet. Kubelet is nothing but but an agent. Okay, and then that agent will talk to your docker daemon. Will talk to the docker daemon. Docker daemon will responsible to create the containers. That is called pod. In Kubernetes we call it as pod. Okay, I will discuss what is this pod and what it is more details. Okay, it is pod. So it will take actions of what needs to be created, pod A, pod B, or what kind of actions you want to be done. Okay, this is how the flow works. And if you see here, the API server, and once this is created, what will happen, the kubelet, if you see here, the agent which will send the response back to the kube-proxy, and then kube-proxy will send back to the API server. Then API server will give the result to the client, kubectl. Okay, now we'll be seeing this controller. What the controller does, actually it is the brain behind this architecture, this master. What happens here, it will be sitting inside the master and will be scanning the etcd database all the time. Okay, it's like a skill, it's a job, like you can say cron job or batch job or anything. Okay, it will be scanning our etcd database. If it finds anything abnormal, if it finds anything abnormal, or any container goes down, or any node not having sufficient resources or anything, what will happen? It will immediately take the action. What will happen? It will just same informations will be set to the scheduler. Then scheduler will take the appropriate action based on the configurations. Okay, now let's see. This is the architecture. Now let's see each component more details. Okay, so this is the pod creation flow, and you should understand and remember it clearly when you are going for the interview or working on a Kubernetes. You should understand how it works, how the pod creation flow works in the Kubernetes. Okay, what happened? As I told, kubectl writes to the API server. So kubectl is here nothing but the client. The client writes to the API server. The API server validates the request and persists it to the etcd, persist it to the etcd. Then etcd notifies back to the API server. Again, API server invokes the scheduler. Then scheduler decides where to run the pod on and return that to the API server. The scheduler will decide when it to be done. Then you will be thinking that there will be multiple nodes will be there, right? There will be multiple nodes, 10, 15, 50 nodes will be there. All the information will be stored under this etcd database. Okay, etcd database, and all this information scanned, everything will be, all the details will be there with scheduler. Scheduler will decide what needs to be done and what pod needs to be created and which server, which node is available. That scheduler will decide and send back the response to the API server. API server then sends the instructions to the respective node, and that respective node agent will capture it through the proxy, and then it will instruct to the Docker daemon to take appropriate action. This is how the flow works. Okay, just imagine the image and the flow, whatever I was discussing with you, and you can correlate everything. You can think how the flow works. Once you see and picturize the flow, whatever I just told you, it's done. Once you remember everything, automatically it will come to your mind and how the flow works. Okay, who sends to where, if you understood clearly. Now what happens once the scheduler decides where to run the pod and everything is done, then the informations whatever is already done by the scheduler will again come back to the etcd, because the scheduler now knows where the pods created. Those informations will be sent back to the etcd database, because the database should be updated. If in a bank, if you go to a bank, if a transaction happened, the transaction details should be updated into the database. Suppose tomorrow is something, we need any details or any further transaction, everything will be checked against your database. So same concept over here also. Okay, the API server then persists all the informations to the etcd database. Then what happens? The etcd notifies back to the API server. API server invokes the kubelet in the corresponding node. The kubelet is the agent here. Okay, and kubelet talks to the Docker daemon using the API over the Docker socket to create the container. Then what happens? Kubelet updates the pod status to the API server, and then API server persists the new state in the etcd. So this is how the flow works. Okay, now, okay, here is the very good things. Just remember, during Kubernetes installations, the following get installed: API server, etcd, scheduler, controller, kubelet service, kube-proxy, and container runtime. Okay, let's see more details about this API server. What is this API server? API server acts as the front end for Kubernetes. This is the front end for the Kubernetes where the client interacts. Okay, The users or the management devices, command line interface all talk to the API server to interact with the Kubernetes cluster. Okay, the API server. Then we'll talk about this etcd. Etcd is the sorry, is a distributed reliable key value store used by Kubernetes to store all data used to manage the cluster. So the database is a distributed reliable key value pair. It stored the data is in the JSON format, right? The key value pair, and all data used to be managed the cluster. The cluster will having multiple servers, multiple nodes, and those nodes will have multiple applications running inside. All those informations will be stored under etcd database. Okay, that is when we have multiple nodes and multiple masters in our cluster, etcd stores all that information on all the nodes in the cluster in a distributed manner. Then the scheduler is responsible for distributing work or containers across multiple nodes. It looks for newly created containers and assigns them to the node. So scheduler is responsible for distributing work or containers across multiple nodes. It actually responsible to take the decision. Okay. It takes the decisions where it needs to be created. The next is the controller. As I told, the control is the brain behind all this architecture and the orchestration. They are responsible for noticing and responding when nodes, containers, or endpoints goes down. So there should be someone who will be watching. There will be someone who will be watching or monitoring the entire system, entire orchestration. If there is something goes down or something happens abnormal, that immediately will be noticed, and then it will send request to the scheduler, and scheduler will take the action. Okay, that's why the controller will be running, and that's why the Kubernetes is very powerful and very useful, because it does the healing itself. We are seeing like self-healing. It also does the self-healing. How the self-healing does, somebody will be there to monitor the health of the system. If the system goes down or something happen, it automatically heal itself, because someone is there to notice and take action. That is done by the controller. The controller, the brain behind the orchestration, they are responsible for noticing and responding when nodes, containers, endpoint goes down. The controller makes decision to bring up new containers in such cases. Some cases, like if the controller sees like something happens to the container, the controller immediately take the action, and it will send the request to the scheduler to make that container up. Then immediately the scheduler take action. Okay. Next is the container runtime. Why the container runtime available? The container runtime will be there in the node machine. Remember, while the installations in the master side will find API server, scheduler, etcd database, and the controller. These four components will be there in the master. And inside the nodes, it will have kube-proxy, kubelet, and Docker runtime. Okay, Docker daemon, you can say Docker daemon or container runtime, it will be there. So in our cases, it happens to be Docker, because we are running the container runtime, we are using the Docker daemon. Okay. Now the kubelet, as I told, the kubelet is the agent that runs on each node in the cluster. The agent is responsible for making make sure that the containers are running on the nodes as expected. Okay, and kube-proxy takes care of the networking within the Kubernetes. Okay, now we'll discuss further on these things. Uh, we are good with this, and here now I'm going to talk about little little advanced one, which you should understand, and you'll get questions also. Okay, here I'm just talking about the stacked topology. So what is the stacked topology? we'll be seeing here the etcd. You can see here when we'll talk about the high availability structure. That means in the master, suppose we'll have multiple master and multiple nodes, because if one master goes down, there will be another master who can take care of the Kubernetes cluster, right? And if you see here the structure in the stack topology, we can see here the etcd database. We have two master now, all are load balanced. Okay, we have two master, all are load balanced, and we have two databases in each master node, and it's separately. This master has the etcd database and this master has etcd database. But in this case, what will happen if one goes down? It will be difficult that all the informations whatever there, it will take some time to be maintained in the etcd database and take appropriate action immediately. It will not the good way to handle. Okay, so instead what we'll go for external etcd. See, people are also using this stack topology, organizations also using, and some organizations are using this, most organizations using this external etcd topology. What is the benefit of using this? And this is very difficult to set up. Okay, compared to this stacked topology, etcd external etcd topology is damn difficult to set off the etcd until unless you are very experienced on Kubernetes administration and orchestration setup. Somebody who is very good and master in this, they can able to write and set up this etcd topology external. So people, that's why follow mostly stack topology, and some companies who are experienced highly or do the setups, they go follow all these external etcd, and that's a very good benefits of external etcd. That's why people are following this. If you see here, the databases are outside of the master node. It will be in a different server. Somewhere it will be placed. That means both the masters, both the master writing these informations to the databases. Suppose this master is active, master 1 is active, what will happen? It will write the informations to the database, both the databases. Now all the informations related to the Kubernetes cluster will be written to the databases. And suppose this goes down, what will happen? This master will immediately take action and it will scan these databases, and these databases will be up to date. It finds the immediate all the informations there, right? Again, when this first master is down, this master will alive or up. It what it will do? It will again start writing all the informations to these databases. In this way, we'll never see any downtime, or we'll never see any um, problem with our database and our Kubernetes cluster. Okay, this is the external etcd topology. Now we'll see. Okay, this is how the architecture, how it works. If you have any doubt, we can discuss now. Okay, or else we'll move further to some installations and we'll see how we can work on that. Okay, this is how the architecture, and I would suggest you just go through the architecture, follow this diagram and the architecture, whatever I just showed you. Just watch this video after the class, go through this and find it, and just remember and picturize this one. Okay, here I have just given one master and one node architecture. There will be multiple nodes when you will be working on the real-time Kubernetes cluster. There will be multiple nodes. Okay, now let's go ahead and do the Minikube installations. We are going for running, so we are going to create a cluster, Kubernetes cluster, using Minikube. Okay, I'll show you how we can do that setup. Okay, so what is the system requirement?
So,
Yeah, please.
so yeah, Ranjit. So, Ranjit, one doubt actually. So, if nodes goes down, so there will be the controller at the master level. So, it will take care. Means it will create another node, or the pod it will create. But if master goes down, so how to means recover it? Just
Exactly.
to know.
Exactly. That's why I told you, right? In this case, what happened? We should have high
Uh,
availability structure setup. We should have multiple masters there. If a master goes down, there will be another master we can take the actions, right? If this master is goes down, if we have one master and one node, in that case, if master is
mm,
goes down, then we are done. We are gone. Then we have to wait and take master. It will take lots of time, and we'll get some. We'll see some downtime. That's why companies and organizations they go for high availability structure. In high availability, there
okay.
should be multiple masters, not single master. Multiple master, multiple nodes attached to that. If a single master goes down, if we have single master node, then it will be a problem. We'll see the downtime. We should have go for high availability structure where we'll have multiple masters. If one master goes down, another master will be there to take the action.
Okay. Okay. So if we are going with the stacked topology, so we can also recover, no?
Yeah, in stack topology also we can
Application
recover, but sometimes we'll see some delays on this. We can see some delay
delay. Okay.
because here the etcd database are there in this master because these masters are totally different, right? Though this is interrelated with the cluster, those it has these are the part of the clusters, but this database will not be up to dated. If this master goes down, the other master will have the old databases because these databases we should have a separate backup or separate separate like backup or up to date program should
Backup.
be there to make these databases backup all the time, right? So but in this case it will be in the external topology, it will be all the databases are externally placed and it can be linked to multiple masters. The database can be linked to multiple masters. If we can have we have two
Okay.
masters now, tomorrow we'll add another master. We can link that master to these databases. In this case, if two masters are goes down, another master will be available to take the action, right?
Yeah. Yeah. Got it.
Okay.
That syncing part, how it will be done, Ranjit?
It will be automatically done by the Kubernetes. Okay, so that's what we have to write the multiple. That's why I told initially, right? If you're highly experienced on that, you have to write a program while creating the cluster. While creating the cluster in the Kubernetes, while creating the cluster in the Kubernetes production environment, you have to write in such cases where you have to sync all the databases with all the master components. Here you can see in this master we have three components in the node, but another component is outside of this master. And that will be while you're creating the cluster and master, you have to write the program to add this etcd database to the cluster to make sync each other.
First time.
Okay,
Single.
and that will be taken care
Okay.
by the
Mhm.
Kubernetes itself.
Okay. Everything it will done by Kubernetes only.
Yeah, but you have to write the program. You have to do the setups while creating the cluster. Okay, you have to
Okay. Uh-huh.
if you don't give instructions, how Kubernetes will know? Kubernetes after giving
Yes, yes. Uh-huh.
instructions, Kubernetes will do all the things by itself, right? But before that, you should give some instructions, right? That you have to provide. Okay. Now let's
Okay.
how we can create the development cluster using the Minikube. Okay. How we'll create a cluster using the Minikube. And using this Minikube, we'll create a single master node server. We cannot create multiple master node server because it is very huge expenditure is required. You have to use more servers. I'll show you the details how we can use, but we cannot create because it will charge you like anything, right? Because we are going to use the cloud services and it is going to use multiple servers, multiple other services from cloud, so it will charge you more. Okay, but I'll show you how we can do that. No worries. Now, the simplest way to do this system requirement, I'm going to do that. So what we need to set up this Minikube, you can set up this Minikube in your local machines also. In your local machines, I have set up this Minikube in my laptop. Okay, in my laptop, in my MacBook, I have the Minikube installed, and it is working. So you can see here one icon is there, right? It's not Minikube; it's a different tool used to create this Kubernetes. You can see here in my this Docker desktop, I have Docker desktop running, but Kubernetes is failed to start. Okay, this Kubernetes is failed to start. I can see here, and I can restart this Docker to make sure the Kubernetes is also working, but I'm not going to show you from my laptop. I'll just create new setup using this AWS server. Okay, so we have to create the cluster. What we need two CPUs or more. Remember, the server should have two CPUs or more, 2 GB of free memory, 20 GB of free disk space, good internet connection obviously, and we should have container or Docker installed into that. Container or Docker installed into that. So what we are going to do then, we'll get a Linux machines of Ubuntu 20 or higher than that. Then we'll see how we can install the Docker. Then we'll install Minikube, and then we'll install kubectl. All these are interrelated. Okay, one by another we have to install it. So let's first get one Linux machine. Okay, I'll just quickly get one machine. See, normal this free tier will not work. Remember, this free tier things will not work because the free tiers will having only 1 GB of RAM, which will you cannot able to install it. Even though you install, you cannot able to open anything. It will slow down because everything will be occupied. So that's why I'm going to use the paid version of some services, and I'll use for some minutes, and then I'll terminate the server. Okay, because it will charge me more. And you can practice. You have to, if for your thing, you have to buy it and you have to practice it if you don't have a good laptop, right?
Because we have run with Windows, so
One
maybe Linux we can take it from there.
sorry, Tapanay.
Because our laptop mostly Windows, no? So because it will be showing on Linux, so maybe we can take from the AWS cloud.
Yes, we have to take, because see, your laptop will have 4 GB RAM, right? 4 GB or 8 GB RAM. 4 GB RAM will not support sometimes. 4 GB RAM will slow down because your laptop will be occupied by some other applications, some other services, right? Some other applications tools will be installed which will be completely occupied. 50 or 70% will be occupied and 30% RAM will be available. If you install Minikube, then you have no, your other applications will not work properly. I would not advise you to
Mhm.
install on your desktop, on your laptop, because it will slow down your total laptop itself. It will not reboot. I have already done my Windows laptop and I have seen that one. If you have 16 GB of RAM or more than 8 GB of RAM, then it is good to install this cluster. Okay, or else it will slow down your laptop. You will not able to work itself. Okay, better you just for training for your practice, just get done this EC2 one. Just get immediately one EC2. Try it to work on 1 hour, 2 hours. Do practice. It they will charge some 50 or 100 rupees. That's okay. You can just do practice and terminate the session. That's it.
Okay.
Okay, guys. So I'm going to get one Linux machine. So I'll go with Ubuntu 20.4. And why I'll Ubuntu 20.4, I'll just tell you. Okay. Now you can see here they have updated the UI. See, now they have updated the UI. Before our classes, we would maybe 1 week or a few days before, the options were totally different, right? They have what opt out to the old experience. Okay, if you want to go to the old experience, means old UI, then you can select it here. Then you
UI.
old UI. Okay, fine. We'll just try out with this new. You have to be because these AWS guys are updating their experience, their interface all the time. They will be sitting the engineers who is designing this UI and giving good rich functionality, rich feature to the customer, right? Okay, so what we'll do here, Amazon EC2 instance we are going to create. So give a name, and I'll just give as Minikube cluster. I'll give Minikube cluster or Minikube server. Minikube cluster. Okay, application and OS image name. So we can search it here, or we can browse for more AMI, right? Now let's go for Ubuntu. Then we should have free tier, right? 24. Okay, free tier eligible. 20 for this and canonical Ubuntu. Mm, okay, fine. I got it. So instance type. Okay. So here I don't have to select T2 micro because T2 micro is having only one CPU, right? But we need at least what we need two CPUs. Two CPUs or more. If I select one CPU, then it will no, we are not able to do anything. It will not open the server itself. It will be hang all the time. Okay, so we need minimum two CPUs. So we have to select. We should not go with free tier eligible. Then we have to select something different, right? Then I'll go with two CPUs. Two CPUs, T2 medium and 4 GB RAM. So it will charge me per hour 0.0496 US dollar. Okay, so let's select this one. I need two CPUs, 4 GB RAM, T2 medium I selected. Okay. Now keep a, just give a name if I have selected okay, Minikube. Network settings. Okay, they have little changed and okay, so allow FS traffic. Good. If you want to edit this network settings and add this network setting, the setups what we are doing is nothing but your security group. Setting up the security group. Okay, now I'm setting up the security group. You can edit it and select existing security group. Let me select if anything. Yes, I have few security groups available here, but this has a little difficult to select because in the older version what we used to get, if whatever the security group and whatever the port is firewall, everything we used to see and then select it. But here in this case we are not able to do that. But let me just select anything like okay, for the time being let's do the simplest one, only SSH or EFCDemo, SSH Tomcat HTTP. Fine. Now I selected one security group, 8 GB configuration. This is the storage. Storage is 8 GB. But how much storage we need? 20 GB of free disk space, right? So we have to increase. Then I'll get. Then it will charge me more price, I think. Let me make it 30 GB. Got it. Okay. Good. Then let's see the advanced details. All these things is not required, not required, not required, not required, not required. Okay, fine. Selected. Number of instances 1. Okay, all done. Let's launch instance. Success. Okay, view all instances. I think the old version of UI was good. This new one is not good. Fine.
Yeah.
Let me refresh it. Okay, so Minikube cluster is now is running, and instance type is T2 medium. Okay, so carefully do that while we're doing practice. Just get one medium instance T2 server T2 medium server, and then just do practice for 1 hour or 2 hours, and immediately once you finish your work or practice, just stop it, not stop it, terminate it. Okay, even though you stop it, it will keep you charging.
Need to terminate.
You have to terminate it. Okay, just terminate it. Okay, now it's running. Let me connect to the.
Ranjit, can you show me the security groups?
Yes, sure. 1 second. Okay, I connected to the server. So security group, right? Yeah. So if you go to the security groups, we'll have all this TCP and all. So these are the the existing. I had given the Tomcat one, right? Whatever we had, but all the security is not required. Only 22 is sufficient. Only single 22 is okay. These are extra is given. Okay, we can remove it also. Do you have any doubt here? We don't have to do any. So far, we don't have to work any security. We can set up the security later also. All these port ranges.
Yeah, no, nothing.
Only thing is we require 20.
Because I could, yeah, because I can see many. That's why I confused.
No, 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 no. Please don't to get confused on this. Okay, we don't need this many things. We simply, I thought why we need to create another security group. Whatever the existing one, I just created it. Okay. Now, okay, if you want to change also, you can change the security group. Copy to new manage tags. Okay, fine. Let it be there. Don't get confused. All these ports are not required. Only 22 SSH 22 is okay. Okay, all this not required. These are all for different practices. Now our server is up and running. I have connected to the server. The first thing is we have to install the Docker. Okay, we have to install the Docker. So here, if I just when I put Docker here, what it says, Docker command not found. That means Docker is not installed. As per our requirement, what we need first Docker to be installed, Docker installation, because we are going to use the daemon or the runtime, Docker runtime, right? That's why you need Docker to be installed first. Let me use this Docker. So here it has given the option how to install this. Just get it, sudo apt install docker io. Docker io has no installation candidate. Okay, let me first update it. Sudo apt get update. Just updating the server first. Done. Let's try this one. Okay, after update, it's working actually. Okay. Okay, so our Docker is installed now. Let's see. Okay, so I can see here our Docker is installed successfully. It's very simple to install Docker in Ubuntu, right? So simply use Docker install. docker.io, it will be installed. Now what is the Docker version? 20.10. So our Docker is installed. Next thing is what we need to install. We have to install Minikube, the local cluster. We are going to do the setups by using Minikube. Okay, so let's start that one. How we install this Minikube? Okay, fine. Here there is one installations. I'll just ping you all these things. You can just copy and keep all this handy. Okay, to create the documentations. I'm just pinging in this chat so that you can also make a note of that. And okay, copy this one. Then what we are going to do next, we are going to install Minikube. I'm just copy pasting all this. So I just downloaded this Minikube Linux MD64 that executable. Okay, same things I'm going to do here. I'm CP changing this one to user local bin Minikube. I renamed this to this one. It's very simple to do that. Okay, then changing the permission, because as this is, if I see here, it will not have the executable permission, right? See, it does not have executable permission. Then I'm going to make this as sudo chmod 755, change it. Okay, now if I see it here, change to executable permission. Okay, so that's done. Then if I do here Minikube version, so it says version 1.25. Okay, so once this Minikube is installed, we need to install the client. We set up the cluster. Now we need to install the client to interact with the Kubernetes, right? To interact with the Minikube cluster. So what is the client? The client is kube control or kubectl. This is also same thing we have to do. We have to just download this executable. Okay, download this executable and then change the permissions and then use it. It's very simple. Nothing is required to do that. Okay. Similarly, changing the permissions, then move to local user bin. Then if I do kubectl version, it gives us the version informations. Okay, now what happens, why it says localhost 8080 was refused? Okay, for that what we have to do, we have to just start this Minikube first. Start the Minikube. Okay, to do that we have to use change some user details. If you can see here, I just use user mode, creating a group and adding the user to that group. Okay, it's done. Once it is done, then we can use to start the Minikube. Okay, Minikube start. Minikube start. So it is downloading the Kubernetes and installing. See, version 1.2.3. What it does, automatically selecting the Docker driver, because we have installed Docker as our Docker daemon or Docker runtime. So it is automatically selecting the Docker driver for us. That driver will be act as the Docker daemon, or it will be work as the Docker runtime, right? Then it is pulling the image of the Kubernetes and it is trying to set up the cluster for us. Everything, we don't have to do anything. Simply use this command and it will do all the setup for us. Okay, just wait to finish it and then we'll start. So you can see it here, right? Creating the Docker container with CPU two CPUs and memory 202 GB. Okay, it's taking 2200 MB. Okay, so it's done now. It's successfully done. You can see here, done. kubectl is now configured to use Minikube cluster and default namespace by default is created. If you see all this message, that means you have successfully created a local cluster using Minikube. Okay. Now if I do kubectl or kube control, kubectl version gives us all the details. Okay, that's okay, guys. So we can now able to install the Minikube server. Now we don't have to do anything with Minikube commands. Now we'll all the classes going forward we'll be using this kube control commands only, because kube control, what is that? kubectl is the client to interact with the Kubernetes cluster, right? Kubernetes API server and all. So we have to use this client CLI, command line interface, to use the commands to interact with the master. Now let's see what are the details we are going to learn now. So once this installations is done, we are good, and the commands are very simple, and I can just ping you the link. 1 second. I can just ping you this link so that you can just also try follow this documentation. Okay, this is the official documentations. What is this? Okay. Now installations is done. So what we'll do first, let's move forward and see what are the other objects and components in the Kubernetes, and we'll discuss further. Okay, we'll now discuss about the components. We have seen this master. Okay, what are the components the master holds? The master holds 4 components mostly, that is API server, scheduler, controller, and etcd database. Okay, now we'll see some concepts. Okay, and this, just remember what are this concept, and we'll again see more details in elaborated way, and see details how it looks like, and see how other concepts can be created. So here, deployments, these are the high level of construct that define an application. Pods is the instance of a container in a deployment. Pod is consist of one or more containers. So what the container holds, can anybody of you tell? It's a question for you guys. What the container holds inside it? We have finished our Docker classes, right? I hope you guys would have done the practices and all. What the container holds?
Our executable binary and supporting softwares to run the binary.
Mhm. That's partially correct. And
Uh,
simple thing is, it holds the application, right? It holds the application and the required binaries and libraries required for the application. Our product, right? Our project, it holds the project, it holds the application, because we are just deploying our application inside the container. The container will now hold our application and the required libraries and binaries. Okay, so now the containers holds the application. Then what is the pod? The pod concept is in Kubernetes. The pod is the instances of a container in a deployment. It's the object of a container. That means the pod is consist of one or more containers. Now the pod consists of one or more container. That means a pod can have one or more containers. One or more containers. But what the container contains? The container contains the application. Okay, the container contains the application. The application is now inside the container, and the container will be inside the pod. The pod holds the container. Remember, we'll just learn more and you will understand clearly when we move forward and hold more details in that. Okay, when we write the program, you will understand clearly. The services are these are endpoints that exposes the network ports to the outside world. So like we saw in our Docker, right, how we access our application inside the container. Same ways we are using the object called services in Kubernetes. How we'll access the application which is running inside a container, inside a pod. How that will be exposed to the outside world. How the customer, how the clients will use your applications by using the endpoints, that by using the services. So the services is nothing but the endpoints that expose the network ports to the outside world. So there are three services we are going to learn in this entire classes. That is node port, cluster IP, and the load balancer. Companies will be using this load balancer services. Node port and load balancer. Node ports in the development environment will see this node ports. In productions, will be using load balancers. Okay. So as I told, the kubectl is the client. We can use kube control or kubectl to create, delete, modify, and retrieve informations about any of these using kubectl commands. Okay. Now, this all about this just concepts, three concepts we discussed. Now we'll see what is a node. We have seen this master and nodes and all this, right? So what is this node? A pod always runs on a node. Remember, we don't run pods in the master in production environment. It's run on node machine. A node is a worker machine in Kubernetes and maybe either a virtual or a physical machine depending on the cluster. Okay, it's a virtual or physical machine depending on the cluster. So each node is managed by the master. Each node is managed by the master. A node can have multiple pods, and the Kubernetes master automatically handles scheduling the pods across the nodes in the cluster. So the master handles everything. The node can remember this bullet points. The node can have single or multiple pods inside it. So every Kubernetes node runs at least one kubelet, container engine, container runtime, or Docker daemon. The master automatic scheduling takes into account the available resources on each node. Okay, so more details we'll discuss in our next classes. So for today, that's all. Maybe we are just getting more details in one day, then you'll get confused. Just try to just watch
Correct.
this video and just go through this architecture. Just try to understand. Make your own note. Make your own note. Take a pen, paper, make your own note, make your own architecture diagram, write it down by watching this video. Okay, and try to install whatever just I told you. Try to install the Kubernetes cluster by using Minikube. Okay, Just do little practices. Once installations is done, more commands will discuss in our upcoming classes, maybe tomorrow. Yes, tomorrow we have the classes, then we'll discuss more on this, and we'll discuss how to handle this, just work on these commands, and you'll see, then you can practice these commands, and you'll get have little fun to work on this. Okay, if you have any doubt, we can discuss, or we can wind up this call and connect tomorrow morning. Okay.